Okay, welcome back. So we're going to do this problem. We're going to find the area between r equals 2 plus sine of theta and r equals 3 sine theta. Okay, so actually you may or may not remember, but let me show you. We did graph one of those yesterday. R plus 2 sine theta. So if you looked yesterday on video 4, we graphed it. So I'll just go ahead and graph that one real quick. Looks something like this. Remember, it was a little acorn thing. No, didn't go there. There. Okay. And r equals 3 sine theta. Well, we know how to do that. That actually is a circle. X squared plus y minus 3 halves squared equals 3 halves, I believe. 9/4. 3 halves squared. Okay, so that's a circle that looks, oh, wrong thing. Like so. Let's make it a little smaller. Like so. Okay, so we're actually graphing not the area that's shaded now, but the opposite of it. We're graphing this area. Okay, so all those graphs, we're going to assume we know how to do that. That's not too bad. We did this one in 9.4, and this one is standard. We've done a couple of these already. Okay, so let's go ahead and we're going to have to check where these graphs intersect. Okay, we're going to have to find the intersection points. Okay, because right now it's like, well, what's going on here, right? So we're gonna set these equal to each other. 2 plus sine theta equals 3 sine theta. Okay, so moving this over, we're gonna get 2 equals 2 sine theta. Sine theta equals 1. So theta equals pi over 2. Okay. What does that really mean? Okay, so let's sort of take. So one of the things to remember is that when you go around this on sine, this is going around twice. That's sort of what they're meaning there. Okay. Again, this one's going to be a little bit different. So what I'm going to do instead, I'm going to take sort of the region, instead of doing it via polar graphs, I'm starting to see, no, I'm not going to be able to do that. What I'm going to do is I'm going to say, okay, this thing has area equals 9/4 pi, right? Pi r squared. Okay, and I'm going to find the area of this region, of this whole region. Okay, so I'm going to take, let's call this A1. Let's call that A. Let's call this A1. Okay. And our A total is going to be A2 minus A1, where A2 is going to be 1/2 the integral from 0 to 2 pi. Now, in this case, we're going to use r is 2 plus sine of theta. d theta. Okay, so we're going to have to integrate this thing. Okay, and that's not a hard integral to do. We're going to write that as 1/2 0 to 2 pi 4 plus, actually I shouldn't say not a hard integral to do. I should say it's a straightforward integral to do. Okay, so we have this. Remember, sine squared is 1 minus cosine 2 theta divided by 2. And if you don't know how to integrate 4 or 4 sine theta, then you're probably in the wrong class and you need to talk with me about changing your registration to Calc 1. Okay? All right, and so I'll leave this for you guys to integrate. These are all pretty standard for you to integrate. Okay? All right, we'll do another one in the next video.